This is a sample problem for half angle, where the problem is we are going to prove that 1 plus tangent alpha times tangent 1/2 of alpha is equal to secant alpha. So the solution starts from, by the formula 5.4, we are given with tangent alpha over 2, or tangent of 1/2 alpha, is equal to 1 minus cosine alpha all over sine alpha. So if you're going to check formula 5.4, here it is. The variable that we are using here is p, which is in replace to alpha based on our problem. So it is equal to tangent times tangent of the half angle is equal to 1 minus cosine of the angle all over sine of the angle. Back to our problem, by defining our tangent half of the angle, we are going to replace the value of tangent half of alpha into the problem formula. So replace this value into this one. Therefore, we arrive with 1 plus tangent alpha, tangent half the angle is equal to secant alpha, or equal to 1 plus tangent alpha times 1 minus cosine alpha all over sine alpha, which is this one, is equal to the right term. Or if we are going to rewrite that one in two lines, it will be the same as 1 plus the 1 is not included with the denominator sine alpha. So 1 plus tangent alpha times 1 minus cosine alpha all over sine alpha is equal to secant alpha. And if we are going to combine the mixed terms, the whole number and the fraction, with a common denominator as sine alpha, we arrived with sine alpha divided by the denominator of this one, which is 1, of course. So sine alpha divided by 1 is equal to sine alpha. Sine alpha times 1, therefore we have here sine alpha, plus the original second term, which is this one, tangent alpha times 1 minus cosine alpha all over the denominator sine alpha, equal to the right term, which is secant alpha. Now let's proceed to the simplification. If we are going to multiply this one, tangent alpha into 1 minus cosine alpha, we arrive with tangent alpha coming from tangent alpha times 1, and then this one, tangent alpha cosine alpha, negative, coming from tangent alpha times negative cosine alpha all over the denominator, which is sine alpha. Next is simplify tangent alpha into sine alpha over cosine alpha. The same with this one, into sine over cosine alpha. And the rest will follow the same from the previous terms. If we are going to rewrite this numerator, it will become to a form sine alpha plus sine alpha over cosine alpha minus sine alpha cosine alpha all over cosine alpha, all over the denominator sine alpha equal to the right term, which is second alpha. Then simplify this numerator. We arrive with a common denominator as cosine alpha. Cosine alpha divided by 1 is equal to cosine alpha. Cosine alpha times sine alpha is equal to sine alpha cosine alpha. And then the same with the second term, which is sine alpha, this one. And then the same the third term, which is sine alpha cosine alpha, which is this one. Next, since this is a positive sine alpha and cosine alpha, we can do a subtraction from that with this one, since it is minus sine alpha cosine alpha, resulting the remaining numerator on this term is sine alpha over cosine alpha. So the same denominator, sine alpha equal to the right term, which is second alpha. And if we are since this is a division of fraction, this is the first fraction, so we have here sine alpha over cosine alpha equal to this one, sine alpha over cosine alpha, divided by sine alpha, or if we are going to take the reciprocal of this one, so it means we simply have to multiply that one the first term. Therefore, reciprocal of this one, sine alpha, is equal to 1 over sine alpha, resulting to 1 over cosine alpha only, since sine alpha can be cancelled with this denominator, which is sine alpha. Therefore, now we have proved the problem, which is 1 over cosine alpha is equal to second alpha, and prove that it is equal to the right term as second alpha.